Hi, my name is Bianca Bertolino, and this is Lab for Oscillations for Physics 2211. The purpose of this lab is to examine the motion of a spring mass system where the mass swings in an arc while oscillating on the spring. We do this by understanding and predicting motion using fundamental physical principles. Some of the important fundamental physical principles that we use for this lab is, again, Newton's second law, the position and update formula and or energy principles, which are kinetic energy, potential energy, energy of the spring, and net force of the spring, and finally the net force of gravity. I decided to go with option 1, where a video was provided for us, and we need to mention that the value of the calibration length, the time between video frames, and the physical characteristics of the system, meaning the mass, spring stiffness, and relaxed length, were the same as the vertically oscillating mass from our lectures. So the mass of the object was 0.402 kilograms, and we used the calibration stick to measure the length of the spring. So with the data we got from the Y mass and the X mass, we could go and move on to the coding part of the computational model using GlowScript. First, I added the initial conditions, which were the mass of the ball, the spring constant, and the relaxed spring length to match our video analysis, and then the code to specify the vector L, which describes both the length and orientation of a spring. And then the next step was to compute the system energies. Now, using the previous code, we have to define our initial energies, so the kinetic energy, the gravitational potential energy, the spring potential energy, and the total energy. And then the next step was to use our force formulas to find the gravitational force and the spring force on the mass by the spring. And lastly, the net force in the last part of the code. And for that, we applied Newton's second law and the update velocity and position formulas. Now let's discuss our results. So in the first image on the left, we see our change in energy versus time graph, where we have the change of energy on the y-axis and the time on the x-axis. And we see that the blue is represented by the kinetic energy, red is the gravitational potential energy, green is the gravitational spring energy, and orange is the total energy. And then on the right, we have our positional graphs of x position and y positions, and we see that the graphs don't match up the model, and therefore this is due to human error. Now, lastly, we discuss some questions. The first one is if the energy principle is satisfied for a model system. And we can say that the energy in the system is conserved, therefore the energy is neither created nor destroyed. And this is because the total energy, delta E, as we've seen in the graph, remains at 0. Lastly, we made two separate estimates of oscillation periods. First, by estimating the period of oscillation from the x position data, and second, by estimating the period of oscillation for the y position data. And when comparing these we see that the x position versus time graph more closely matches our model, and therefore we calculated the period estimate using x to be 1.5 seconds, the spring constant to be 4.67 newtons per meter, and the relaxed spring length to be 0.0356 meter. Thanks for watching.